Example 5 in chapter 29, it follows up this whole thing called the simplex algorithm. And what the basic idea is that once you've created a feasible region, the vertices of that feasible region are going to maximize whatever equation we come up with. Often we call it the max equation or the profit equation. And you always want to maximize or minimize depending on your situation. Now, the situation that we have in this question, we're trying to maximize, say, profit. And so what we need to do is graph it, determine our feasible region, determine our vertices, and then sub them into this equation. And the largest value we get here will be our best choice. So if you think about this in context, if I were doing this with apples and oranges and I wanted to maximize how much profit I'm going to get, these could be profit equations, and the vertices would allow me to pick the best situation for how many apples and oranges to sell to maximize my profit. We'll get into word problems with this, and this is kind of where they go anyway. Now, so our basic 2, our x greater than 0, so we know that side of the line, y greater than equal to 0. So those two are pretty obvious. Now what I'll do is I'm just going to call this equation 1, equation 2. Notice how I numbered them up here? That is there. I numbered 1, number 2, now number 3. If x is equal to 0, 3y equals 18, so y equals 6. So there's the y-intercept. If y is equal to 0, I have 2x equals 18, so I have 9. Draw my line. And this is equation 3. Now the other one, 4x equals 24. When y is equal to 0, 4x equals 24. So that means x equals 6 right there. And y equals 8 when x equals 0 for equation 4. So we get this. Here's equation 4. Everything, the feasible region is going to be here. Because it's good, the only area that's going to meet all the constraints. As soon as it's less than, greater than, we end up in that situation. So now our vertices, 0, 0, is 1 right here. Then we have 6 and 0. Three and 4. And then 0, 6. So it's pretty obvious 0, 0, maximum is going to be 0. 5 times 0 plus 4 times 0, 0. Then we have 5 times 6 plus 4 times 0 equals 30. 5 times 3 plus 4 times 4 equals 15 plus 16, 31. And then 5 times 0 plus 4 times 6 equals 24. So our maximum is 31. And so that's where we're leading into when we get into the word problems. Hopefully you guys can read these. It looks pretty tiny. That's example 5 from 29.